In continuing on with our videos about right angle trigonometry, in the past example I was showing you, in the past video, sorry, I was showing you about how right angle triangles work, and depending on how we name the sides, we have a relation of what we call sine theta, cos theta, and tan theta, depending on what opposite and adjacent and hypotenuse values are. We saw that these tan, cos, and sine actually mean something to do with real graphs. I taught you a little trick to remember them, so, ka, toa, just to remember which way they go. Now I want to show you this, this one here. If we actually want to work with this, if we want to do a real example, it really helps to be able to talk about what mode you should be on your calculator. So on your calculator, this is an important thing to note. Your calculator, always make sure you're in degree mode. In other words, not radian mode. That's because the way your calculator calculates angles, it depends on how you're defining the angle. If you're doing the angles in degrees, or what we're going to talk about later on called radians. So for example, on the TI-83, I can press my mode button. See this one right here? I'm going to press it. If I go there, I can see all sorts of different things that it's using, but the important thing is look at the third one down. See how right now the radian is in black? I want to make sure I move my arrow to the right and press enter to make sure I'm in degree mode. Now I want to exit this, so I use a little yellow quit. Since these are color coded, I go second quit. That gets me out. Okay, so just to explain a little bit, that's what we want to make sure. Our calculator is always in degree mode. Always. Now if we want to do an example, maybe we can do that here. So I'll give you an example here quickly. So maybe you're skiing or snowboarding or something like that. Some people always argue what's better, skiing or snowboarding. I think it depends who you talk to. But let's just say you're interested in going down a hill. So your hill goes down maybe something like, maybe some sort of hill like this. Now, assuming that we can actually, figure out, whoops, I don't need a dotted line. I can just make it like this. So this is you kind of skiing down the hill, so to speak. So there's you on your little skis, or maybe on your snowboard or something like that. The question is, we want to find out this angle here. We want to know that angle. Now, what if you're told that this side right here is 22 meters? In other words, you go down 22 meters every time you go across maybe 40 meters. You could do that. If you had a GPS, you could actually figure out how far you've gone and how far you've dropped, so to speak. So if you know that you've gone down 22 meters every 40 meters you go across, the question could be, what's your angle? In other words, so what is the angle of the slope? Now we can easily use our tricks from before, so, ka, or toa. But first we have to know what to name these. So first of all, which of these looks like the 90-degree angle? I hope you see it's this one right here. If that one's 90 degrees, that means this side right over here, oops, make sure I'm in the right color. This side over here becomes the hypotenuse. And that's because it's the longest one, and the longest side is always opposite to the 90 degrees here. Well, that means which one then of these sides becomes adjacent and opposite? Well, remember, if this is the angle here, this one across from it becomes opposite. If that one's opposite, well, the other one then is the adjacent. That means beside. Okay, so beside it. But remember, this one here is not adjacent. That one's the longest one. So this is H. This is going to be called A. This is going to be O. So which of the so, ka, or toa, so to speak, in other words, sine is opposite over hypotenuse, or cosine and tangent, which of these should I use? Well, I always try to look at which ones do I know. I don't know the hypotenuse length. Do you see that? I don't know this length of this side here. I don't know that one of this triangle. But I do know O. I know opposite. I know O. And I know A. That means I'm looking for one of these three that only has O and A in it. In other words, I don't want to use that one. I don't want to use that one. I'm going to use this one because it's only got O's and A's in it. So I'm going to write it out in full just to make sure I know it. So tan theta, it's important to always write it. It's not just tan by itself. Tan on its own means nothing. It has to be tan of something. So tan of theta is going to equal, well, O over A. So in other words, opposite over adjacent which in this case then, let's fill in the values. Opposite over adjacent, that's going to be 22 divided by 40. So in other words, tan theta is 22 over 40. Now here's the problem though. I want theta by itself, not tan. A lot of people think, oh, we'll just divide by tan. But tangent is a weird function. It's weird in the sense that you have to be tangent of something. In other words, it's not so simple. You can't just divide by tan to get rid of it, because it's not tan times theta. It's actually some strange reserved function called tan of theta. In other words, tan and theta are sort of glued together. You can't really separate it. But we want theta only by itself. So how do we get rid of a tangent? I'm going to show you a little trick on your calculator. At least the TI-83 and the 84 are written in a nice, or at least designed in a neat way. Take a look at the sine key. That's sin. And you've got cos and you've got tan. Well, what I like is that look at the little yellow version of it. So opposite to sine is called inverse sine. It's a little sine with a little power of -1. And you've got cosine is to the power of -1 here. And you've got tan to the -1. Those are opposites. By the way, if you want to see other nice handy tricks for that, getting rid of squares is square root. Getting rid of log is 10 to the x. Getting rid of natural log is e to the x. So these ones here and these ones here are actually in a really nice way. So in this case, pardon my digression there, but if you want to get rid of tan, so to speak, it's going to be what we call inverse tan of 22 over 40. You can do this on your calculator. Watch here. I've got my trusty calculator here. So I'll do, I like to do the 22 over 40 first. So I'll do 22 divided by 40. I'll press enter. Now I want to do the inverse tan of this answer. So I'll do second tan. See, it's inverse tan of what? Of course, I can type in 0.55, but I like to use this little yellow ants right here, answer. So I'm going to go second, press this button here. So in other words, inverse tan of the last answer, that gives me 28.8. So in other words, I could say then that my theta is going to be approximately, it's not exactly, so I put a little dot, 28.8 degrees. Or if I wanted to round it up, then I could say then, you know, it's approximately 29 degrees. If we're just rounding to the nearest degree. This is a pretty typical slope for skiing, by the way, or snowboarding. A lot of people think if they're skiing, you know, on something it's 90 degrees, but trust me, it's not. Anything more than about 45 degrees, snow has a lot of trouble sticking to it. Although I can tell you if you're on the slope, it certainly seems like a lot steeper than 45 degrees, but it actually rarely is. So a slope, for example, of 29 degrees is pretty alright. That'll work pretty well for skiing down it. You'll have snow and you'll be able to actually slide down. So see how we can use trigonometry. We can apply it in all sorts of examples. Maybe we're doing steepness of hills, or maybe we're just trying to find where someone is, so just by finding angles depending on sides. So as long as you know some side lengths and some angles, or you want to know an angle and you have some side lengths, you can use this SOHCAHTOA. In other words, you can use sine, cosine, and tangent as long as you've set it up the right way and as long as you've double checked that it's a right angle triangle. As long as it is, then you can use it. It's a very, very powerful tool for finding all sorts of answers.